Of all the worlds in our celestial neighborhood, one has captured a distant crimson point of light, promising the infinite possibility of a second genesis for humankind. This is the driving force behind centuries of inquiry, a quest that has consumed fortunes and lifetimes since the first telescopic observations in the 1660s. Our red neighbor, in so many ways a distorted mirror of our own world, could one day become a new home, if only we can decipher its ancient secrets. The most tantalizing of these secrets is the ghost of water. For generations, we have seen the evidence etched into its rust-colored terrain, the unmistakable scars of ancient riverbeds, vast deltas, and deep lake basins. In an earlier age, before precision telescopes and robotic emissaries, astronomers squinted at these markings, imagining them to be great canals and flowing seas, the work of a dying civilization. Today, we know the truth is both more subtle and more profound. There is no liquid water flowing on the Martian surface now, but the geological record screams that it was once there, perhaps thousands or even millions of years ago. And where there is water, there is the potential for life. It is the crucible from which we ourselves emerged, the universal solvent for biology. The frozen ice caps that still cling to the Martian poles are a remnant of this wetter past, a final, solid trace of a lost world. Scientists now believe the planet's small size and thin atmosphere were its undoing. The atmospheric pressure, a mere 1% of Earth's, is too tenuous to hold liquid water on the surface. Any that existed either boiled away into the vacuum of space or retreated to its frozen sanctuary at the poles. Yet the planet's mysteries run deeper still. A topographic map of Mars reveals a world cleaved in two. One hemisphere, the north, is a vast, smooth expanse of low-lying plains. The other, the south, is a rugged, ancient world of crater-scarred highlands and colossal volcanoes. This great planetary dichotomy, a division that runs almost perfectly along its equator, is one of its most enduring enigmas. What cataclysmic event in the planet's youth could have forged such a stark and fundamental difference? Was it a colossal impact from a rogue protoplanet, or some unknown internal process that shaped one half so differently from the other? Theories abound, but not one has been proven with 100% certainty. Each new mission, each rover that touches down on the ochre soil, is searching for clues to this primordial puzzle. For in understanding Mars's dramatic past, its lost oceans, and its divided nature, we seek to understand the fragility of worlds, including our own. The story of Mars is not just about another planet. It is a cautionary tale and a beacon of hope, a narrative of what can be lost and what might one day be found. What other truths lie waiting, buried beneath the silent, crimson dust? To gaze upon Mars is to see a world divided, a planet of two starkly different faces. The southern hemisphere is a testament to a violent past, a scarred, ancient landscape of highlands and craters. The north, by contrast, is an expanse of vast, smooth lowlands. This profound dichotomy has long been one of the planet's most enduring riddles. One theory speaks of a cataclysmic collision, an impact of such unimaginable scale that it reshaped an entire hemisphere. The primordial ocean of magma. This molten rock forged the rugged mountains and deep valleys of the south, features we can trace with precision today. The still hot lava then bled northward, a planetary-scale resurfacing event that buried older terrain, leaving the northern hemisphere eerily flat. Yet another possibility suggests the answer lies not in a blow from the heavens, but in the slow, grinding pulse of the planet itself. Some scientists speculate that Mars once possessed a system of plate tectonics, an engine of geosculpted the two distinct hemispheres over eons. But this remains a ghost of a geologic past. As of today, we have found no conclusive scars, no definitive proof of such movement. The mystery of the two Marses remains unsolved. But the planet's surface is not the only source of intrigue. Its thin atmosphere whispers another. In the early 2000s, instruments detected the faint but unmistakable signature of methane. On our own world, this simple gas is overwhelmingly a product of life. Its presence in the Martian air was a tantalizing clue, immediately fueling speculation that microscopic organisms could be breathing, living, and dying beneath the crimson dust. Of course, geology can also produce methane, releasing ancient gas trapped within rock. To understand the difference, researchers turned their gaze to one of Earth's own frozen archives, Greenland. Deep within the ice sheets, they found methane that had been locked away for many thousands of years, produced not by geology, but by tiny microbes. These bacteria thrive in extreme, oxygen-deprived conditions. Given the harsh realities of Mars, it is entirely plausible that similar organisms could survive there, their metabolic byproducts slowly seeping into the atmosphere. The ultimate question, however, remains: is the methane we detect a mere echo, a chemical ghost from a long-dead ecosystem, or is it the faint, continuous breath of life that persists, hidden and resilient to this very day? Each plume of gas detected is a clue in the greatest detective story of our time, a search for a second Genesis on a silent neighboring world.